first off, sorry I couldn't make it out there. We had a few delays here with pandas. So these guys here are pandas. Pandas are universal car interfaces, meaning this thing has 3 CAN buses, 2 LIN buses, and a GM LAN bus. And on the computer side, it has USB and Wi-Fi. And these things sort of lead into what I want to talk about today. The winners of the self-driving car race are not going to be anybody today who's building cars. We have a poster in our office and it looks like this. It says, "This is why we don't build cars." And this here is a picture of the Zoox. We call it the Zoox Jalopy. The truth is, who won in smartphones? The 2 companies today that have dominated smartphones, Apple and Google, before 2007 had never built a phone before. It was not Motorola, it was not Nokia, it was not BlackBerry, it was not LG. In fact, this weird sort of thing happened with the companies that were further along in the smartphone race, before the real smartphone race began, actually ended up falling the hardest. BlackBerry and Nokia both don't exist anymore. The low end, like Samsung, well, you remember Samsung phones in 2004? Which had more props, flip open a Samsung phone. They ended up growing into the second biggest phone manufacturer, high-end smartphone manufacturer after Apple. So self-driving cars are entirely a software problem. And like I said, that's where Panda comes in. Panda bridges the hardware from your existing car into reasonable, easy-to-use software. Cars have ports that look like this. Every car manufactured after 1996 has this port. It's called the OBD2 port. And computers have ports that look like this. Every computer manufactured after 1996 probably has something close to that anyway. This also has Wi-Fi. Once you've done that, the literal question is only software. Well, okay, so some older cars have things like hydraulic power steering, or brakes that couldn't be electronically actuated. Pretty much every newish car is already gas by wire. So the gas pedal in the car is not actually physically connected to anything. It's just a potentiometer that goes through the ECU, and then that runs the engine. The brakes and the steering are usually still physically connected, but the steering controller in almost all cars after 2012 is electronic power steering, not hydraulic power steering. The reason for the change is fuel efficiency. With electronic power steering, you don't have to run the pump continually. There's this middle ground electro-hydraulic power steering where the pump just fills up the hydraulic reservoir and reruns needed. But electric power steering means that even though the steering column is still physically connected, there's a motor on there, and the motor can provide enough torque to turn the wheel. If you're in a modern car with modern brakes, like with ABS and traction control system, particularly with traction control system, because ABS, you're using the pressure that the user's already applied on the brake pedal, but with traction control system, you need to be able to apply the brakes even when the user isn't. So there's going to be some sort of pump to build up hydraulic pressure and valves, right? So if you have a pump and valves, and they're reasonably rated, you can get it brake by wire. So that's, every car is gas by wire. Electronic power steering is a steer by wire, and these pump and valves is brake by wire. So with Panda and a bunch of clever software, you can actually control cars. You can turn many cars into a drive-by-wire car. We sell for $75,000 a Prius development kit. And what that is a Toyota Prius that we've modified the firmware on, as well as a Panda, which lets you have full control of the car. Now, if you want to turn a car into a self-driving car, because like I said, there's really, and a lot of people will try to sell you on this idea that cars need to change to become self-driving. They don't. The car is pretty much the same. Just as from a high level, glossy over perspective, sure, maybe they lost keyboards, maybe they got a little bit bigger, but phones fundamentally stayed the same. What changed was the software. So you have an interface. Now what we need to do is figure out how to get a lot of computing power into the car. And today I'm going to show you guys some stuff that has never been seen before outside Comma.ai, except for yesterday by the press, because it doesn't go live for another hour. And I'm going to give you the URL so you can check that. So on the right here, or I guess the left, the one with the video, that's our new website, which you can check out at preview.comma.ai. And this is our new shop at shop.comma.ai. So in the shop, we have obviously Canvas shown you, but we also have our newest product, the EON Dashcam DevKit. Now, this is not a self-driving car. For regulatory reasons, we don't sell self-driving cars. We sell dashcams. But one of the key components is very similar, right? So you're going to need some way to make your car drive by wire. You're going to need some set of sensors, and you're going to need a good amount of processing power. With these three things combined, you can turn any car into a self-driving car. So you have actuation, you have sensors, and you have compute. This is the actuation component, and some sensors too. Remember, cars have sensors. Actually, maybe more apt are these things. These are giraffes. This one's for the Toyota, and this one is for the Honda. What these do is let you read even more sensors from your car that are not on the OBD port. Many cars have CAN buses that are not on the OBD port. So yeah, this gets you into that radar CAN bus. So now you have a radar, and this device is a dash cam. And of course, if it's dash cam, it comes with a camera. So this is the EON Dashcam DevKit. It ships with. So we've taken our Openpilot. Openpilot is our open source self-driving car software. And for, we've removed the part that actually drives the car. We're not at the point yet where we're ready to sell a product that actually drives cars. Self-driving is it's a multi-step process. We want to be there, but we want to get there in the right way. So we do have this software called Openpilot. We've taken components of it, like the sensor components of it, and like the nice management software, all the parts that are non-controversial, and we've put them into Shipper Plus, which is a repo that will go live on our GitHub in less than an hour. Shipper Plus is it's dashcam software. Dashcam, step one, we get into the compute, we get the actuation, we get the sensors. Once those all come together, and you have high reliability from the hardware, you can start focusing on high reliability of the software. And then after that, you have a fully self-driving car. So, for those of you who don't know, we have software called Openpilot. And Openpilot is available on GitHub, github.com/comma.ai/Openpilot. I'm not sure how visible these screens are. I don't really have a back panel to find out, but I'll tell you the URL so you can play along at home. So what Openpilot is think about the phone ecosystem before every reasonable smartphone you buy today is either iOS or Android. iOS is all controlled by one company, by Apple. So we think of Tesla, kind of like the iOS of self-driving cars. They're out there shipping Autopilot. Maybe you have GM shipping the Super Cruise, which is like the Symbian. Volvo shipping the BlackBerry OS, Drive Pilot, right? In the long run, none of these are, Autopilot's going to do well. The Model 3 does well. So Autopilot is good. And they have the right sort of sensors and the right sort of compute and the right sort of way of thinking about it. Super Cruise, You know, I've heard good things. I've actually heard that the experience itself is good, but I look at that and it's missing OTA. It can't do OTA updates. So whatever I buy today as GM Super Cruise is what I'll have in 3 years. They say they can update the map, but if you can't update the software, it'll look so atrociously out of date in 3 years. I mean, just think about a smartphone you couldn't update, right? Think about a smartphone that literally came with the shipping software and how out of date it would be in 3 years. Now, for phones, this is mostly okay because everybody buys a new phone. You know, most people, I think the average replacement time is like, it's 18 months, 24 months, sure. The average life of a car, at least on US roads, it's 9 years old. Cars get replaced much less often than phones, of course. It's a lot more expensive. So what we focus on here at Comma.ai is how do we take existing cars and basically give you a Tesla Autopilot-like experience. So with this Comma EON Dashcam, it's not just a dashcam, it also comes with Waze and Spotify. Because this is what you want from a, I'll bring it up on the left TV here. Because this is what you want from a car dashboard. Okay. Like you want a great dash cam, you want great music, and you want great nav. And I mean great, right? You don't want the nav, you don't want the Mercedes-Benz stock navigation system brought to you by Navtech. And it's like, no, I want Waze, right? Oh, do you want Slacker radio? Do you want Pandora? No, I want Spotify, right? And we get to leverage all of this because the operating system that these things run is called NeoS. And NeoS is a fork of Android. It's open source. Check it out, GitHub/comma NeoS. But yeah, so Openpilot right now is supported on the Acura ILX, the Honda Civic, and the Honda CR-V. But pretty soon now, once we get it past final testing, we're going to add support for the Toyota RAV4, the Toyota Prius, the Toyota Camry, and the Toyota Corolla. And with that said, though 5 of those 7 cars are some of the top 10 selling cars in America, we should get the Honda Accord as well. And that will be 6 of the top selling cars in America that support our software. Now, it's a little bit different from phones because in the phone world, phone manufacturers would bundle the phone with Android. But here's the difference. When the iPhone came out, I was there. It made a big impact on my life. Every phone manufacturer realized that they were used behind and they needed to copy it. And they did. When the Tesla Model S came out, I didn't see the car companies do the same thing. This is a Paul Graham tweet. He's like, the Model S is the thing that the car companies should have started copying 5 years ago. And when you look at the architecture of it, when you look at the architecture of the Model S compared to like the architecture of Chevy Bolt, the Model S has powerful computers running Linux, running like Ubuntu, modern software development architecture. The Bolt has a few small ECUs. You need big compute, big sensors, and reliable actuation in order to make your car self-driving. And self-driving is not a level 4, level 5. I mean, this stuff is a Google-invented myth, largely. I don't see this as like the way the industry will play out, maybe for trucking. Because in trucks, you can afford a $150,000 sensor package because you'll recoup it. I don't know if people have actually done the math on how cheap Uber drivers are, but you know, they're not. $150,000 capital cost is a lot. You better pay in person. That's why our stuff is at the price point it's at. So this is $699. This is $99. You know, obviously it's not an Uber driver yet, but maybe we're 1/10 of the way there. Maybe a $10,000 full autonomy package is a whole lot more reasonable. Yeah, maybe Google will be there. Just look at the apples about the automakers. So automakers, I talked to them, they seem to have this idea that like, okay, here's what you need to build self-driving cars. You get HD maps and LiDAR. You have your integration engineer connect them together, and then you have a self-driving car. And to me, it's very obvious that this doesn't really work because Google has the best LiDAR in the world. Google also has the best HD maps in the world. Yeah, their car, well, the Waymo car is super impressive. They should pivot to trucking and get those things on the road as quickly as possible. It's not as good as a human at driving. Now, Google also has a huge advantage in AI software, so if we're talking about who's going to get to level 5 first, I would heavily bet on them. But not because of their LiDAR or their HD maps, just because of their big machine learning advantage, basically. But yeah, so what do we have today? How are we going to solve the problem? We have, as one of the things we do, a dashcam for both iOS and Android. And we're big fans of dashcams because what dashcams do is let us get, this is called Shipper. It's available in the Play Store and the App Store. What dashcams let us do is understand how driving really works. What is the definition of driving? I don't think there's a way to come up with a definition. I don't think there's a way to write out a spec or write out a program that implements what driving is. Driving is a dance. Driving is a super sophisticated dance done by highly intelligent agents, all acting in a multi-agent capacity, right? The only way to model systems like this and to become superhuman at them, at least from what we've seen, is huge data, right? So that's what we do. You can check out, they always tell me that I shouldn't make this public, but I'm a little transparent person. On beta.comma.ai, we show off how many miles we've collected, and yesterday we just passed 2 million. It's not even 2 million, it's not too many, but we have 2 million miles of video data of driving. We have countless numbers of scenarios, and we also have, if you check out our Twitter, we like to show it off, sophisticated machine learning, which is capable of taking those videos and understanding them semantically. We label objects, we label movable objects as movable objects, unmovable objects as unmovable. We know the approximate depth of things. So this is like our depth map. And this is just running on one of the videos we get from the dashcam. I don't know how visible, again, the screens are, but yeah, this is on our Twitter, and it's cool stuff. So we have a depth net, we have a segmentation net, we have a pose net, and then what we're going to start to do is train all these nets together unsupervised. So we're recovering the semantic information about what objects are, the depth of objects, and how the camera moves through space. How the camera moves through space is also how the car moves through space if you assume they're rigidly attached. And with that, you can understand what driving actually means. In this scenario, where do I go? Not, okay, and I've talked to some tier ones for this. Let's write an 80-page book on every possible driving situation, because you'll never get them all. Imagine an 80-page book on every Go situation. We're going to write up, okay, so this is a Suji, this is an Atari. It's never going to work. What did solve Go was huge data and a lot of self-play. Self-play in this case is simulation. What's going to solve driving? Huge data and a lot of self-play. It's a lot of simulation. But yeah, I wonder if there's any way we can do questions. I'm happy to take questions.
Oh, okay. So, do you have any questions?
Did my camera lock up?
Yes, we can't see you anymore. We can hear you loud and clear.
Can't see me anymore. Huh. Let's see if I can fix that.
Oh, bravo, okay.
Bravo, okay.
Cool.
Great. Do you have any questions?
Do you have any questions?
Okay.
Okay.
You guys can start to tell us.
Like doing some basic shell
So I love this
So it's not this crowdsourced approach to building out the data set.
Can you tell me about
Some of the people taking part in that, and obviously there will be questions around this.
So about who's taking part in the data collection effort?
Yeah, could you talk a little bit around the community that's involved?
Sure. Yeah.
Crowdsourcing of this data, and also, I guess, gradually some of these community members will actually engage the self-driving on a personal basis, taking on that risk themselves. So maybe we could talk about that a little. Thank you.
Sure.
Should I repeat back my question to the group?
I'll kind of state it.
Okay.
So the question was about who is the Comma.ai community? Where did these 2 million miles come from? So many of them came from our dashcam apps. So we have 2,000 users of the Shipper app, about 2,000. We have for people who built common Neos and are running Openpilot. It really is an incredible community. You know, back in the day, there were a lot of people who would mess with cars. But as cars became more and more software, they became less and less approachable for the kind of person who knows what a torque wrench is and how to replace a transmission and what an engine hoist is. And, they became more accessible to people who know how to like jailbreak phones and video game consoles, right? So I'm trying to bring this back. We have a great community. You can join our Slack, slack.comma.ai, and chat with some of them. And yeah, some people have decided to download our open source software and install it on their car and experience really the latest and greatest on autonomy and improve it themselves. So who are they? It's really cool. It's really cool watching people like join a community and come together and work on stuff like this.
Great. Here.
Yeah.
Okay, good.
Okay, good.
Time for
Time for maybe one big question.
Zach?
Hey, this is Zach from Clean Technica. You mentioned that GM isn't able to do over-the-air software updates. My understanding was that the Bolt was able to, but it wasn't really rolled out commercially yet. Can you speak more? It seems like you have different insight. I'm sure more technical insight. Can you speak more about what their OTA, over-the-air update capability is versus what we're used to with Tesla, for example?
Sure. So the question was about GM's OTA ability. I don't work at GM. These are a combination of things I've read on the internet and things that I've heard from certain sources. But I've heard that GM is not going to be able to OTA their cars. They're shooting for 2020. So Tesla has this great OTA process where basically they drop a zip file onto the main Linux computer running Ubuntu and it updates all of the modules. I know less about the Bolt architecture, but from what I've seen, there is no sort of powerful central computer like that. They're not. All of Tesla's cars are on a VPN. They connect back to this thing called it's called Mothership, and from what I've seen, GM just doesn't have this. And I'm not sure why car manufacturers don't go right for OTA updates. Because I think it's this kind of misguided notion of security, right? We can't have OTA, it won't be secure. What scares me so much more is when your car has fake OTA, like the Jeep. The Jeep had OTA updates. Some of these cars that are out there have OTA functionality. It just wasn't coded in by the manufacturer, right? If you have something that is at all physically connected to the same buses, even if there's an isolation gateway, I can get a packet to me that I can update your modules over the internet. Whereas somebody who thought about OTA and the security considerations from day one won't do this. So I don't know. From what I heard from one inside source and from just reading stuff on the internet, GM doesn't plan to have OTA on their cars until 2020. Take it with a grain of salt. I don't work that.
Thank you, George. That's all the time we have today. Thank you for getting up at some ungodly hour to talk to us.
Cool.
Appreciate it.
All right. Thanks a lot, guys.